Okay, let's talk about quadratic functions where you're just given the equation instead of the graph or the sketch. The first thing you need to do is figure it out if you have vertex form or standard form. In this case, we have parentheses with something squared, which means that we are in vertex form. Vertex form is important because it is a times x minus h quantity squared plus k. So when we're looking for our vertex, which is the ordered pair hk, we are going to pull the h out from the parentheses and then take the k as that last part outside the parentheses. Okay, so notice that there is a minus in the formula and a minus in the equation. Because the formula says x minus h, whatever comes after the minus is going to be our h, which is 5. And then our k is what's ever added or subtracted on the outside. It says plus k, but we have a minus 6, which means that our answer is going to be negative 6 for k. Really confusing way to think about it, I know. So let's try two other ways to help you out. To find your h coordinate of your vertex, you take what's inside the parentheses, set it equal to 0, and we wind up with x equal to 5. And that's where we get the 5 that's positive inside our vertex. The k is whatever you add or subtract at the end. If it was positive, we would have a positive value. The other anecdotal way to think about this is that our h value is hiding in the parentheses or the house with the x. We all have some x in our lives that we don't really trust, okay? They say up, they mean down. They say left, you know the answer is right. So when you are in the house or the parentheses with your x, you cannot believe what they say. They're saying it's negative 5, so you know the answer must be positive 5. If they were to say, oh, it's x plus 11, then you know the answer would be negative 11. And once you're outside of this house, outside of the parentheses, life is exactly how you think it should be. Up is up, green is green, left is left, negative 6 is negative 6, which is why we don't change it in the vertex. Yeah. We had discussed what our leading coefficient, the a, does for our problem. And here, a is 4. Since a is 4, which is greater than 0, which means it's positive, our graph is going to open up like a cup. So it looks like that. If our graph is opening up, that means our vertex is hanging out down here. And if our vertex is hanging out at the bottom, that means that our vertex is a minimum. For our domain, remember your domain is your x's, whatever you can plug in for your x values. And in this case, our domain, because we have a quadratic function, is always going to be all real numbers, negative infinity to positive infinity. But make sure that you keep your open parentheses around the infinities. I'm going to skip the range for a second. Our axis of symmetry we already found. Back up here when we had x equal to 5. Remember that our axis of symmetry is x equal to h, which means that when we found our h value of 5, our axis of symmetry is x equal to 5. And we need to know where our function is increasing and decreasing. Okay, so I'm going to draw my parabola. We're opening up. Oh, that didn't show up very well, did it? Let me try a different color. There we go. All right, so we got our parabola. We know that our vertex is hanging out at the bottom because it was 5, -6, and our graph is opening up. Okay. We already found our axis of symmetry at x equal to 5. Okay, so from here, we can find our range, because remember, our range takes us from our smallest y value to our largest y value. And since we are opening up, this guy right here is the bottom, which means -6 is our smallest. With our range, we can put our bracket around the -6 because we actually hit -6. And then we're going to open up, which means we're going up into the positive infinities, which always gets a parenthesis. Let's go back to our graph to talk about increasing and decreasing. Remember that we read from left to right. So if we approach our graph, from left to right, we are going down. Get my graph back. There we go. Which means that we are decreasing. Because again, we're going down. And on the other side, once we hit our vertex, our turning point, we start going up, which means that we are increasing. And this helps us figure out what our intervals of increasing and decreasing are. So remember that we're using our x values. Okay? So you know negative infinity is on the far left. That vertical line was x equal to 5. And then on the far right is positive infinity. We just said that in this first interval of negative infinity to 5, that we were decreasing, which was going down. And that means on the other side, in our second interval of 5 to infinity, again with parentheses around everything, we said that we were increasing. So if you can draw it, we didn't even need the graph, but I am going to show you what the graph of this looks like so you can double check all of your answers, but you still need to be able to do this all by hand. So I'm using, of course, Desmos, my friend, the graphing calculator. I'm going to plug my function in exactly as I see it written, and Desmos will start working its magic as I go. Yeah. So if you notice, we have the vertex at the very bottom, which is 5, -6. It's our turning point. Our graph is going up, which means that our leading coefficient is positive. Our range we still have the lowest point hitting the y-axis at -6. I just graphed this line so you could see where the point was, since I can't highlight it right now. You can see that our axis of symmetry is x equal to 5. It split our graph completely in half. It's my green line right now. And then you can see that we are reading from left to right, decreasing because our graph is going down. And then vertex, we switch up and we are increasing. So you can use your graphing calculator to double check, but remember you have to be able to do all of it by hand.